Hello once again. So today we will be reading this paper. Let me speak freely. A study on the impact of format restrictions on the performance of large language models. So, if recently you must have heard that OpenAI announced JSON mode, 100% accuracy on the JSON mode on the latest language model offerings, like for GPT-4 and GPT-4o mini. And JSON mode is a very important aspect of being able to integrate LLMs in backend applications, because it gives the consistency of the output, which is really important for the robustness of applications that are built on top of LLM. But there is a serious question involved here. Like if you uh, have some sort of these format restrictions like JSON mode, or you can have your output in XML or maybe in YAML format, then how much performance degradation can we expect, or does it come with any cost of performance degradation? So this paper tries to address those questions. And before we begin on this paper, uh, the authors have mentioned the limitations or the things that were not in the scope. So they have tried a lot of models, like they have tried Claude and yeah, hi. Just to give one the context one more time, we today will be reading this paper. Uh, Sorry, today we'll be reading this paper about the the performance degradation on the to answer the question if there is any performance degradation when we apply any particular format restriction on the output of LLMs, for example, JSON mode. And yeah. So before we begin, a key limitation of this paper is that though the authors tried different models like Gemini, Claude, and GPT 3.5 Turbo, they have not experimented with GPT-4 and Llama 3.1 models, which are better in their reasoning abilities. So that is one limitation, and they are primarily focused on two types of tasks. First task is which involves some sort of reasoning, and a reasoning task would be something like GSM 8K, where the language model has to output a particular expected answer. And the other type of problem is the classification problems, let's say for multiple choice questions, which are basically cases where the model has to predict a particular output between fixed set of options. And yeah, and one more thing before we go ahead, if you are interested in just the TLDR of this paper, the authors are basically suggesting in this paper that whenever there is a particular reasoning heavy task, it is much better that in the input instructions to the LLM, we keep the format specification a bit loose. So instead of trying to give a very hard or very specific schemas in which you would rather prefer the output to be, it is much better to just give them a loose schema. And we will discuss about this shortly, how that happens. Yeah. So there are different methods of structured generation that the authors have explored. The first one is the idea of constraint decoding, which is also known as the JSON mode, and it is available. I think it is available through Anthropic and OpenAI both. And in OpenAI API, if you have ever tested them, there are, for the later models, there is a specific field in the chat completion mode where you could just enable the JSON mode. So in constraint decoding, what happens is that during the inference time, the models are the allowed set of tokens for the model is restricted, so that they are forced to adhere to a particular output format, which in JSON mode is the expected format, is the is that of a JSON. And another way to restrict the output of the language model is to give, format restricting instructions. So if you give a prompt like, um, given this paragraph, can you return me a question and the answer in a JSON format? So where you can give instructions to the model directly like this, and that would and you can give the instructions directly in the input to the model, and you can this allows the users to experiment with different output formats like JSON, XML, and YAML. So here uh, whatever the way we want the output to be becomes the part of the instruction itself. And the third way that the authors have Yeah, and the third way the authors have explored the out structured generation is they have yeah. Any question? Yeah. So the third way the authors have explored the structured generation is getting a natural language answer from the language model first, and then using some sort of an external parser which converts that output to a fixed format. So this generally is like a two-step process. So let's say you gave a prompt to GPT 3.5, and it gave answer in free flowing natural language, and on top of this you use another LLM to convert that answer into a fixed format or like a JSON mode. So these are the three main methodologies that are used by the authors to explore the structured generation paradigm. And talking about the experiments, first we'll discuss the data sets that were used for the paper. So the dataset comprise of two main types of tasks, as we discussed earlier. First one is the reasoning tasks, and the second one are the classification tasks. So under the reasoning task, there were three dataset that the authors are referring here. The first one is the GSM 8K. It is a collection of mathematical problems which reflect daily life scenarios, and so it's bound to have some sort of a not very high and complex reasoning, but reasonable enough reasoning which even some LLMs find hard. Another uh, dataset is the last letter concatenation dataset, in which given a text, the LLM needs to produce a string by concatenating the last letters of a sequence of words, which again is a decent enough reasoning task in which it will have to uh, do reasoning over the entire context that is given as the input. The last reasoning dataset is that of shuffled objects, where the LLM has to we will the evaluation happens on the ability to in, infer the final state. Yeah, sorry. Infer the final state given an initial state of, let's say, objects and a sequence of shuffling events. So if uh, uh, Yeah. So if let's say we are given a state of objects and then we have given a shuffling order, then the LLM has to figure out what will be the object at the last. Uh, at the last, what will be the last state of after the shuffling? So these three reasoning data sets are like reasonable and not very tough reasoning. They are not questions like that involve solving math Olympiad problems, but they are reasonable reasoning task. And there are some classification tasks, classification data sets. I think we don't need to get into the details of what these four data sets are, but the idea is that the authors are trying to evaluate broadly on two sort of task. One is reasoning task and another one is classification tasks. Now, talking about the different models that the authors have used here for comparison. uh, yeah, so they have experimented with GPT 3.5 Turbo, Claude 3, Gemini 1.5 Flash, and they are using llama 3b 8b instruct and gemma uh, sorry yeah gemma 2 9 billion instruct model to evaluate evaluate the open source models that are available. And the evaluation method, so they are using two kinds of matrix. The first metric, especially for the classification task, is the accuracy. So the model, whatever the accuracy yeah, accuracy is pretty self-explanatory. And for the reasoning based task, they are using the exact match of the output as compared to the input expected input answer. And there's one important thing, since LLMs are known to be very prompt sensitive. Like, even if you replace one word with a synonym in the instruction, there is a high chance that the model uh, may change the output that it's going to give. So, and especially for format restricting instructions, it becomes quite important to test different ways in which you give the model input in free flowing text. So to address the nature of this prompt sensitivity, they are experimenting with three types of task descriptions, three JSON, XML, and YAML schemas. So the idea here is just to make sure that to try to get the same kind of answer with different, yeah, with different variations of the initial input prompt. And to give a little bit more context to the people who joined later, sorry to go here again, we are discussing this paper, let me speak freely, and a study of the impact of format restrictions on performance of large language models. And the reason we are discussing this paper today is because a lot of backend applications and applications that rely on LLMs for their output are known to use something called a JSON mode, or they expect the models to behave or give output in a specific format, and that helps in the robustness of the applications. But uh, s- but a serious question whenever we go use the JSON mode is that, does enabling these format restriction bring down the performance of the models or not? So to continue where we left off, so till now we have discussed what is the idea behind this paper, the three main methods of how they are focusing on generating structured content. First one is the constraint decoding, which is the JSON mode, which I think people who have used OpenAI API would have already used. Another method is format restricting instructions, where you give the expected output as a instruction itself. So let's say if you want the output as a JSON, you just mention in the instruction to give output as a JSON. And the third way is to convert whatever the natural language response is to a specific format, which is like a two-step process in which first you give the answer, and then another LLM will parse that answer and it will convert to the specific format that we are seeking for. Now, talking about the results from this paper, and as I said earlier, that there are the limitations that the authors have not tested on very big newer models like GPT-4. But it is the results are good for someone like me who's also working as a developer, to understand where to use the JSON mode and when to use JSON mode and what things to keep in mind while using it. So let's start with the impact of formal restriction on final results. So the authors say that their findings suggest that the degree and implementation of format restrictions can significantly impact the LLM performance, particularly in reasoning tasks. So what they mean to say is that, based on their experiments, they have noticed that when it comes to reasoning based tasks, if you uh, add a restriction on the output format, then they have noticed that there's a drop in the performance of LLMs across multiple LLMs. And then another interesting thing that was present in this paper was that when it comes to classification tasks, format restriction, especially the JSON mode, helps in improving the performance of the model. And I think, and the authors are hypothesizing that this is because with the constrained output requirements, the model is much more focused on just answering the question, and there it's not giving any particular additional text, which is like a big problem with the LLM. So if you ask an LLM one particular question, it will, instead of just always returning the answer, it will give you some explanatory text also, and that behavior most probably comes through the RLHF training that happens after the initial pre-training of the LLMs. So when it comes to classification based task, the JSON mode actually improves the performance of the LLMs. And later on, the authors say that these findings uh, suggest that the format restriction impact on LLM performance is actually task dependent, and stringent formats may hinder reasoning intensive tasks but enhance accuracy in classification tasks that require structured output. So this is like one of the main key takeaways of this paper. And another interesting thing that they highlight is like if you are bound to use these structured format for a reasoning based task, then the author suggests that instead of trying to give very hard schemas or very strict schemas, you can just give a very loose schema as the input, like here. So reply your answer in JSON format with the following schema of reason and the answer, as you can see on the screen, instead of giving them a very strict schema of what type of object the reason should be and what is the expected output format. So when it comes to reasoning based tasks, it makes much more sense to give this very loose schema as the expected input or expected output to the model. Yeah. Yeah, that's what they're saying here. Practitioners may want to consider using looser format restrictions when dealing with complex reasoning tasks while still maintaining some level of structure to facilitate downstream processing. Yeah. Any questions till now?
I don't think there is any question here, sir. Then you can proceed.
Sorry?
I said I don't think there is any question here. You can proceed.
Okay. Thank you. Thanks, Hamza. Yeah. So going ahead, now the authors are trying to question like what is the performance across different formats. And they're saying like if we ask the model to output JSON, or if we ask the model to output XML or YAML, which of these languages are actually more preferred or are better suited for different LLMs. And let's go to figure 4. Da, 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 da. Just a moment for German. Yeah. So here, basically, they say that these structure format, the capability of these model is consistent for all these expected output languages, except for few models where, for example, Gemini model is JSON is much more consistent when it comes to JSON output. But yeah, when it comes to structured output, both all three of these languages are consistent enough, and yeah, we can use all three of them for structured generation. Uh, Another aspect that they're trying to address here is the format of the structure format and the parsing error rates. So especially for when it comes to the method of natural language to converting them to a separate format, there is an additional parser that will be used here, and it turns out that there might be the authors hypothesized that there might be an error element because of the error in the parser, but they find out uh, that this performance gap is not the primary factor which is involved in the performance of the LLMs, and thus this factor can be ignored when it comes to the performance results that they get. Yeah, and if this particular table was actually quite interesting. They found out that across all these models, right? I'll zoom in a bit. Yeah, across, let's say, Gemini 1.5 Flash, Claude 3, GPT 3.5 Turbo, and Llama 3, 8 billion models. Uh, constraining schema constraints like the initial three methods that we discussed generally dropped the performance as compared to free flowing text. You can see here, and this is the comparing results without and with schema constraint. Adding schema not only increase the sensitivity to the prompt but also degraded in the average performance. Now this is not for a classification task. This is basically for a reasoning based task, and whenever there's an schema constraint, like when you're trying to force it to be in a particular format, at that time there is a expected drop in performance. It's not huge. For example, here you can see for this JSON mode, for this JSON expected output, it is 89.66, but when there is a schema constraint, it comes down to 89.21. So that is another thing to keep in mind for like this allows us to see how much, but this is for Gemini. If you see the same thing from for cloud, you will see that the after a schema constraint the performance drops radically, and it goes from 86 to 23.44. So this table allows us to think about the if we are trying to use JSON mode with cloud, we have to keep this in mind that there can be a significant drop in cloud's performance, whereas for Gemini we can expect the performance to stay similar. And yeah, so quickly wrapping up. So the key takeaway from this paper, I'll just rephrase once more, is that when it comes to reasoning based task, it makes much more sense to give a very loose schema to the LLMs rather than giving them very tight schemas where we give the input, the schema descriptions, the expected type of the object that we are seeking. When it comes to reasoning based tasks, it makes much more sense to keep the uh, expected output schemas very loose, and if there is any error in the schema, any formatting error or some sort of a syntactic error in the schema, that can later be removed by another round of parsing. And when it comes to classification based task, it is much better to the JSON mode actually does much better, and not just JSON mode, the constrained output sorry, the format restrictions actually help the performance when it comes to classification based tasks. And yeah, that's pretty much it from my side. Any questions?